Kaplan-Meier estimation is used to measure the fraction of subjects who survived for a certain amount of survival time t under the same circumstances. It is used to give an average view of the population. This method is also called the product limit. It allows a table called life table and a graph called survival curve to be produced for a better view of the population at risk. Survival time is defined as the time starting from a predefined point to the occurrence of the event of interest. The Kaplan-Meier survival curve is the probability of surviving in a given length of time, where time is considered in small intervals. For survival analysis, using the Kaplan-Meier estimation, there are 3 assumptions to be taken. Subjects that are censored have the same survival prospects as those who continue to be followed. Survival probability is the same for all the subjects, irrespective of when they are recruited in the study. The event of interest happens at a specified time. This is because the event can happen between 2 examinations. The estimated survival time can be more accurately measured if the examination happens frequently. That is, if the time gap between the examinations is very small. The survival probability at any particular time is calculated as the number of subjects surviving divided by the number of people at risk. The censored subjects are not counted in the denominator. The equation is given as follows. Here, Ni represents the number of subjects at risk before time t. Di represents the number of the events of interest at time t. For the survival curve for the Kaplan-Meier estimate, the y-axis represents the probability of the subjects that still hasn't experienced the event of interest after time t, where time t is on the x-axis. To see how uncertain we are about the point estimates, we use the confidence intervals. The median time is the time where, on average, half of the population has experienced the event of interest. Like the Kaplan-Meier figure, Nelson-Allen figure also gives us the average view of the population. It is given by the number of deaths at the time t divided by the number of subjects at risk. It is a non-parametric model. This means that there isn't a functional form with the parameters that we are fitting the data to. It doesn't have any parameters to fit. The formula for the Nelson-Allen figure is given as follows. Here, Ni represents the number of subjects at risk prior to time t. Di represents the number of the event of interest at time t.